We're going to talk about Java. Java. It's an old language, but it's getting a ton of new features and it's getting better and more fun every day. And to tell us about a latest project, Amber, is Billy Corrando from Oracle. He's developer advocate, and he's going to tell us all about it. Can't wait.
Awesome. Thank you for that introduction. Let me go and get my screen shared again. There we go. And I know it's a bit weird to see me wearing a mask. Unfortunately, I just went to an in-person conference and I did come back with COVID. And to make sure I'm not spreading it to anyone in my household, I am currently wearing a mask because I kind of like an opener household. But sounds like I think I sound okay. So hopefully you can get through this. So with that said, I'll go ahead and get started. As mentioned, my name is Billy Corrando. I'm with Oracle, part of the Java developer group. And you can find me online at Billy Corrando on Twitter, where I spent way too much time. And in this presentation, we're going to be talking about how Amber is driving Java's evolution. I think we should be able to ask questions, correct? People can type questions into the chat for me to see. Right, Mark?
Actually, going to have people type in onto our Slack channel. I'm going to post the Slack link into our chat. They've been using it all day, but I'll be reading the questions to you at the end of the presentation.
Okay, at the end. All right. So in that case, yeah, ask questions, and then at the end of the presentation, yeah, Mark, please relay those to me, and I'll be happy to answer any questions you might have. But please ask them. I'm here to help share and learn about Java, of course. So definitely do not be meek when it comes to asking questions. And again, you can find me on Twitter at Blake Corrando. Tweet at me, DM me, either. I'll be more happy to answer your questions. Of course, you can also feel free to email me at billy.corrando@oracle.com. And then you can link to these slides at my GitHub. If you leave with an intense desire to know more, the team I'm on at Oracle, we have a lot of great resources for learning more. We have dev.java, where we have tutorials and then links to finding other great conferences like here at Philly ETF, and there's many more as well. Also, get involved with your Java users group. There's a great Java users group based in Philadelphia, the Philly Jug, appropriately enough. So, that's a good way to get connected with other Java users groups. That's how I got started as well, was through a Java users group. So definitely do that. Inside Java gives you kind of inside look, which is kind of maybe particularly relevant with what I'm talking about here with Project Amber, about what's going on inside the actual OpenJDK project. So, really good to hear from like the actual engineers writing all the new features that we're looking forward to, what's going on. Every Monday, or almost every Monday, I did miss this last Monday because, well, the aforementioned COVID kind of just had me under the weather, but I usually publish a 1 minute long video to Twitter on various Java features. So definitely check that out. And then we also have a YouTube channel with the Inside Java Newscast and the Jet Cafe, which gets you up to date on what's happening in Java and also deep dive into various Java features. That said, let's get started this actual presentation with all this bureaucracy out of the way. So Project Amber, if you haven't really heard about it, the goal of Project Amber is to explore and incubate smaller productivity-oriented Java language features. So Project Amber is but one of several other currently actively developed OpenJDK projects. There's also Project Valhalla, Project Panama, and Project Loom. And I always kind of thought it was interesting how these names came about. And for the most part, it's somewhat obvious. So like Project Valhalla, Project Valhalla is about improving the memory model map and introduction of value types. Well, value types are often defined with val in languages, so thus Project Valhalla. All right, well, Project Panama, okay, that also makes sense. Improve the interface between the JVM and native interfaces. The Panama Canal famously connects to the Atlantic and Pacific Oceans. Ergo, Project Panama is connecting the two metaphorical oceans of Java and then native interfaces. And then, we have Project Loom, I think probably one of the most anticipated projects, which is, of course, what's it going on there? It's improving the thread handling of Java, versatile threads. Looms read together threads, thus Project Loom. So Project Amber, I'm a kid of the 90s. Initially, I was kind of thinking like this is like a tongue-in-cheek reference to maybe as Mark and I were talking about, like project, Java is kind of old, slow. It seems to be behind like other languages and features, like it's stuck in Amber or something. Like I was thinking Jurassic Park, something like that. And indeed, we have like a little Duke image for Project Amber, which is Duke stuck in Amber. But that's not it. It is way nerdier than that. Project Amber is actually based upon this book series of books, The Chronicles of Amber, and the original passage was walking the pattern. Pattern matching is a popular feature or popularly new concept within Java that Amber is exploring, which we'll talk about a little bit later. But that's where it came from. But anyways, yes, Java is developed by a bunch of nerds, and I even say that as a fellow nerd. So with that said, yeah, Project Amber is about improving language features to make developers more productive. A couple of other changes have already been delivered by Amber. Local variable inference type, or var, and text blocks. I won't be covering those, but I will be covering a few others that have been delivered. And then we're going to be looking into the future as to what Amber will also be delivering later on. So the agenda is we're going to be looking at some of these key language changes delivered between 11 and 17, the themes of these language changes, and then, like I said, the future of Java. Okay. Not being responsive. There we go. All right. So the key language changes I want to cover is the updates to switch, pattern matching for instance of, records, and sealed classes. So for switch updates, these were added in Java 14, and the JEP for that is 361. Now, if you're not familiar with JEP is a JDK enhancement proposal. And so whenever there's a somewhat substantial amount of new work being added to the JDK or just being done to the JDK, it can in fact be also done for deprecations or removals, that is defined within a JEP. And so 361, you can go to here where it says openjdk.java.net JEPs, and this gives you the full list of current JEPs. And so if we go to like 361, then this gives you an explanation on this feature, like a summary, what it's trying to do, history, motivation, and all of that. This is a great source of information to go to that can give more depth and, again, background on why this new feature is being added. I can really give in this presentation because, each one of these could easily be half an hour to an hour in of themselves. So definitely go there as well if you're more interested in learning a little bit more about these individual features. So that said, JEP 361 is updating switch, which included several changes. So like the actual switch or the actual JEP name is switch expressions, but it's a bit of a misnomer because it's more of a change than just adding switch expressions. So of course, we're all familiar with the colon syntax for switch, like in this example here. However, it's quite verbose. There's a lot going on here, even for this 7 case statements. And there's also a lot of opportunity to introduce bugs because we have to put this break here with every case. So if we were just to do some development on it or testing or something like that, and we maybe accidentally commented out the break for case 6, all of a sudden when we match on case 6, it's going to fall through to also case 7, resulting in a bug or a potential bug if that wasn't our intent. So with switch, we added this new arrow syntax. And with the arrow syntax, when it matches on a case, only the code to the right of the arrow is executed. So we no longer need to put a break statement. And this makes it much more compact and easier to read. Also added with switch was the ability to write a switch as an expression, like in this example. So now when we match on a case, we can yield a value out of it. So if I match on case 1, I'm going to return, or I'm going to yield the value of Sunday, case 2, Monday, and so on. And of course, but what's also switch, or when it's written as an expression, we need to have it be complete or exhaustive. In which case, that often will mean you'll need to have a default case. In this example, I'm throwing a value, or I'm throwing an exception. Of course, you don't have to throw exception. I could just return an empty string or something else as well in this case. when you're writing things in the if there was a case when you're writing things in the arrow using the arrow syntax, that you wanted to have like a more complex execution, you could also create a block, like in this example here. When you're writing as an expression, you would need to have the last line end with a yield that will return whatever value you're going to have, or have it throw or something like that. Sorry. But yeah, that can be done as well. Sorry, dry throat. You can also write a switch expression using the colon syntax, and then you would just put yields instead of breaks within it, because this would end the execution within that case. As I mentioned, when you're writing this expression, it has to be exhaustive, and most of the time, right now, that will mean you'll need a default case. However, if I was switching across an enum, like in this example, and I cover all the different values within enum, then I wouldn't need a default case within the expression. And of course, that would be the same case for with the colon syntax as well. So pattern matching for instance of, this was added in Java 16, and its JEP is 394. And as I mentioned in the introduction, with how Project Amber got its name, pattern matching is going to become a very big part of Java in the future. And pattern matching for instance of is the, well, first instance of that. So again, we've all maybe done instance of a few times in our jobs, but it's again somewhat messy to look at. This is a little bit messier because of the comments, but there's again opportunities for errors. And if I had like a long, if a string or if a number or several different types you can match on, it would look a lot more confusing. Pattern matching for instance of makes this a lot easier, and it's also null safe as well, so we don't have to worry about any sort of null handling in this example. But yeah, with pattern matching, what it does is there's a predicate. In this case, the test of is actually a string, an instance of string, and if it is a pattern variable that is then assigned the result of the predicate, or the value on the right side of the predicate, that is then flow scoped. And that's a new concept really within Java. And what flow scoping is that this variable, the pattern variable, is in scope wherever the compiler knows it has been set. So in this case, in most cases, it will be like in this following if block. But to dive a little bit deeper on that, so here, once again, now my string is in scope here, of course, and then it's in scope in the following if block. But it would be out of scope here because the compiler doesn't know it has definitely been set, because obviously this could be false, and then the code would still execute here, and it wouldn't know if now my string has been set or not been set. And then also we can see here within this evaluation block, now my string would be in scope within here to the right of the predicate, but it wouldn't be in scope once we get outside of it. You could get a little weird with it, not that I recommend it, but just to show what this new flow scope concept is like. And and so here, oops, there we go. In this case, because I'm doing a not, now my string would be in scope within the else block, but then or here, because I'm doing a not and then throwing within the if, it would be in scope outside of the if, but it wouldn't be in scope inside of the actual if statement then. So, don't do this stuff, because it'll be very confusing to look at, and it'll be very easy to introduce a bug. But this is again to introduce and understand what the concept of flow scope is, which is then again, basically it's in scope wherever the compiler knows the predicate was true. One quick moment. Sorry about this. Still a little bit sick, I guess. All right, so records, these were added in Java 16, and their JEP is 395. I think records are going to be one of the biggest new features added to Java since lambdas and streams back in JDK 8. And so the first and immediate benefit we see from records is, well, that it helps reduce verbosity. I know this text is a bit small, intentionally so. Here, it's just like, let's just imagine you have like a method and you're taking in some values and you need to assign it to like some throwaway class, or you're just gonna, that only makes sense within the body of that method. If you wanted to define within that body of method, it often takes dozens of lines of code to write even the simplest of classes. And this is what it would look like, and you would lose all meaning. Now, this can be all accomplished within a single line with records, where you define the name of the record, all the fields, and then you can use that record as with later on. And this, of course, then helps preserve the meaning. And this is an example of a local record. This helps preserve, like, say, the meaning of the method where it's defined in. But of course, that's not the only point of records. The real purpose of records is the transparent modeling of data as data. Within this definition of the record on the previous page, we immediately know, okay, the name of the class is going to be all the fields within that class, first name, last name, title, and then, like in this case, Twitter handle. So we know like pretty much all we need to know about this class just from the definition of it. And that can be achieved because records have several constraints on them. One, their superclass must always be Java laid out record. And so as a consequence, they cannot be extended, they can't be abstract, and as a result, they're implicitly final. So that way they can't have any sort of inherited behavior to where you would have to then look at that superclass to understand it, to like what's going on. All fields are final and are shallowly immutable. So if one of these fields was like an array list, I could add or remove items from that array list and that would be fine. But I couldn't change it out with a different type or a different list reference. You can't declare any instance fields, field initializers, or instance initializers. So again, that's about making sure I can just look at the definition of the record and really understand all there is about it, without any sort of like, okay, by default, first name might be John and the last name might be Doe by default. That's not real. That's not allowed, at least for the instance, by having some sort of default initializers. But as a result of these constraints, that compiler will automatically generate accessors, hash code, toString, equals, will all be automatically generated. Though these can be overwritten, though of course make sure, particularly with hash code and equals, you're not going to be messing up the invariance of it. That obviously, if you don't make it to where equals properly does equals, you're going to really have some bugs there. But fundamentally, these are just classes. And then let's see, the last item would be seal classes, which is added in Java 17, and the JEP for it is JEP 409. So what seal classes do, it allows you to kind of really put in some of that domain logic that we all have at our organizations. Every organization I had, there's like certain domain concepts like transaction types, account types, in this example, users, where there could then be certain like limited types that could extend off it. Like there could only be, there's like a transaction and there's could only be maybe a 2 or 3 or 4 or some limited number of different transaction types. Before in Java, you couldn't really ever model that. But now with sealed classes, you can have a class define what class subclasses or interfaces can, or what classes can implement it in the case of an interface. So here we have user, and off a user, we say only guest, customer, or admin can be a type of user. And then all these different the outlines for all these boxes do have meaning as well. So user is a sealed class, and that's why it's a dashed line. Guest is a final class, and that's why it's solid. Customer is itself non-sealed, which effectively makes it a normal class. And then admin itself is also a dashed class. When you define a sealed hierarchy, the subclasses of it must be declared as either final, non-sealed, or sealed. And what it looks like in code is like this, where you would have, you just have sealed class, and then the optional permits clause, which is then admin, customer, and guest. And these are only classes that can extend off a user. And like I said, then admin would have to declare if it's going to be sealed, guest is final, and then customer is non-sealed. One moment. All right. Sorry about that. Also, you can do, so as I mentioned, records, they can't extend classes, but they can implement interfaces. And this could be a great way for records and sealed classes to work together, where you can have a sealed interface and then have records implemented if you also wanted to do that. So I also mentioned, so like in a previous example a little bit earlier of doing a sealed hierarchy, we have the permits clause. So the permits clause is only needed, or the permits clause is optional. And if you defined other classes within the same source file as a sealed class, then the compiler would assume that those are the only classes that could be part of that sealed hierarchy, in which case you don't need a permits clause in it. So this permits is actually optional. So like in this example here, these three classes, admin, guest, and customer, are all in the same source file as user. As user. And so that's why there isn't a permits clause in here. So permits is optional with sealed. It's not actually required. It's when you're going to have it in the other source files, which is often going to be probably the case. But just so you know, you don't have to have a permits. But yeah, this is what the overall Project Amber timeline looks like as of Java 17, as far as what classes are, what features are now standard. There is currently, as we'll be seeing here in just a moment, switch patterns, which is currently going into its third round of preview in JDK 19. But what are the themes? What are the broader goals that we're trying to accomplish with these changes, and not just, here's a bunch of nice new features that we're trying to add? One, we're trying to make things more expressive. So more meaning can be more easily derived from the code, kind of like, early on when we were looking at the updates to Switch, the meaning of that code was somewhat difficult to devise, just because there was so much structure around it between the break statements and just how the structure of Switch used to be. You're more looking at the code versus the actual business meaning of the code. And so like when we got arrow syntax, it became much more clear what the business meaning of that code was. We're also trying to make it safer, and this will be something a little bit later, but like a lot of pattern matching is a lot more null safe, because null is already checked and handled with the pattern matching. So you don't actually have to do like is not null and then do a check on it. The pattern matching does that for you. Also, like in the case with like records are much safer when it comes to serialization. Not that serialization is used a whole lot right now anymore, but it does address a lot of security issues when it comes to serialization, which, well, that's like a whole 3 presentations in of itself. Definitely, that you can feel free to, tweet at Stuart Marks or someone if you ever want to hear more about the serialization issues, because that's like one of the major issues that we wish you could have corrected earlier on with Java. And yeah, as I mentioned, fewer concerns with null, because pattern matching handles null much more safely. But yeah, it's also not just about reducing verbosity and ceremony. It's not just about typing. The literal amount of time it takes to type out, a switch statement using the colon syntax versus a switch statement using the arrow syntax is trivial. It's, most of the time with our jobs, we're trying to think up a solution, not actually type it out. But it's about reducing opportunities for bugs by not having to write a break statement for every case within a switch. You're reducing the opportunity for getting to write that and then introducing a bug. not having to write out, a class every time you want to just have a simple data handler. Instead of just needing to write a record, you're reducing the opportunities of having a bug like that. Even though like a lot of times like IDEs can handle a lot of generating a class for us, if I was to go back and then add like a new field to like that person object or that person class earlier, but then I forgot to recalculate and update equals and hash code, again, that could be an opportunity for a bug. Where with a record, if I just added a new field to it, well, when the code is built and compiled, well, obviously the Java compiler is obviously rebuilding a new hash code in equals. So a bug isn't being written or accidentally added where a new field isn't part of the equals or hash code. So, yeah, I think these are some of the important themes are being added that, what it's really building towards. But also, I think Brian Getz put it best, the Java language architect, where it's just making it easier to program in plain data. And again, that's becoming also more relevant that as, microservices aren't quite the trendy thing they used to be anymore, but still, we're not quite also building the huge monoliths like we used to before. So we're operating much closer to those data boundaries. And of course, also things like serverless is still pretty relevant, where we're very often operating at those data boundaries. So it becomes more important to be able to easily transform and manipulate this data versus actually kind of operating within like a massive monolith where maybe we're not doing as much as that data transformation like we did, or where we wouldn't had to depend so much on data transformation. So that's it. Let's start looking into the future of Java. And one moment, I need to blow my nose here. All right, so yeah, let's get into the future of Java. Oh, wait, I don't know how that got in there, but yes, I am a robot from the future, and we're going to be looking into the future of Java. Now, that said, like big red blinking lights, the future isn't written, it can be changed. As we're looking particularly farther into the future, a lot of this stuff can change. And indeed, from the first time I gave this presentation late last year, I think in December, to now, switch patterns have changed. So I think I've had it updated. I think I have it updated for this presentation, but that's just an example how some of this stuff could change into the future. So don't like necessarily take this syntax and be like, well, this is what it said. Billy said here back in April that this is what switch patterns are supposed to look like, or this is what record patterns are supposed to look like, and now they're different. They could change, but it's just giving you an idea of what we're trying to head to with some of these things. And of course, also timelines can change as well, as we know as developers. So pattern matching for Switch, it's currently in preview 2 for JEP 18 or for JDK 18. It's soon to be in preview 3. I think currently the JEP draft is here. I don't think it's been moved into mainline quite yet. I haven't checked since I gotten back from the conference to see if that's been updated, but I don't believe it has been. Actually, we can go in and quickly check. Has it been? No, it hasn't been. Yeah. So no, it hasn't been. Okay, cool. This is still all correct. All right. So what this looks like is, well, introducing pattern matching for Switch. And so what we talked about earlier about what pattern matching looks like, well, that's what we're still seeing here again. We're doing the predicate here in this case is the case is it an integer? Is this case? So in this case, it's switching on some sort of like this class object. And it's like, okay, if the type of the class is an integer, then assign it to the pattern variable I, and that variable I will then be in scope to the right of this arrow, of the arrow operator. But an even better way of looking at it is like this, where, okay, so like imagine, okay, it's going to be an integer. And if it's an integer that is, that is a positive number, it's greater than 0, and it's an even number, then, it's going to match on this. If it's an integer and it's greater than 0, it'll, but it's not even, then it's going to be odd. But what we can see here, because the compiler, because this pattern variable is only in scope to the right of the arrow operator, I can actually reuse this variable label for each of the following case statements without having to come up with like some other arbitrary different variable name. I don't have to come up like with integer x for here and integer y for here and integer z for here. I can continue to use I in all these cases because, well, that maybe is what makes most sense. So that's kind of nice and much more simple. And that's where we kind of see how pattern or flow scoping kind of really makes intuitive sense that I is only in scope for here in this case, and then this is a different I, and then this is a different I variable. But yeah, also with pattern matching for switch also is able to handle nullability. So if you did want to specially handle null for some reason, you could do that. Otherwise, if it was null, it could just be handled as a null pointer by the JVM. So you don't necessarily have to handle null to be able to do default or something like that. Also with pattern matching for switch, it can also read the structure of sealed hierarchies. So like going back to the sealed hierarchy I showed earlier with record and the sealed or the user interface is I can create this switch expression. And because I am covering all the different values within this sealed hierarchy, then it knows, and I don't need a default statement because all the different possible execution paths are covered. And this gets back to where the safer I was talking about. Let's say I had a sealed hierarchy, and initially I wrote this switch expression that we maybe initially only had admin and customer types, but then at some time later we added guest. Well, this would give a compiler error because it's no longer exhaustive. So that's how I can prevent a bug from occurring in your code, because now there's a check to make sure that, in this case, this switch expression is exhaustive. So that's, again, how things get a little bit safer going into the future with some of these new language features. Record patterns, it's currently in candidate status, and its JEP is 405. And so, yeah, record patterns. So this is another way of how records are going to become even more powerful in the future. They're already very useful, as we saw, but they're going to be continued to be built upon to where they're just going to become a much more stronger and powerful feature. And of course, one of the first examples of that is pattern matching being added to records. And I probably want to update this example because it's a bit abstract. But here, if like we had like this bit of a hierarchy of code where I wanted to get to like the specific field 2 levels down within an object hierarchy, and I wanted to be null safe, I had to first be like, okay, is rectangle not null? Okay, then get like a field out of it. Is that field not null? Okay, then get a field out of it, and then print that value or do some business meaningful work from it. Again, the structure of the code and the null safety of it can become distracting to how the code or to understanding the business meaning of the code. Here again is pattern matching, reducing verbosity that not only reduces opportunity for bugs like forgetting to do a null check, but also makes it easier to understand what your code is trying to do. So now I'm doing an instance of, a pattern matching on a rectangle. I don't have to do a null check because, again, the pattern matching already handles null for you. So in that way, if it gets to this, it knows it can't be null. But then I can also just go ahead and extract values out of that record. I can extract the each of the upper left colored point and the lower right colored point from it, and then directly draw a value out of it. Or I can just even do it farther because these are both records to where I can just directly reference each of those components out of that record and get to those values. And then all of a sudden, in just a single line, I can get to the value that I really want out of it without having to do a bunch of ifs and null checks and all of that. So again, it's safer. And then it's much more, you can see much more the meaning of your code from it. You're not having to do a bunch of extra checks for it. All right, so let's get a little bit further out into the future. The first thing I want to talk about array patterns. So originally array patterns were part of JEP 405. It's supposed to be both record patterns and array patterns, but that was divided out just because it was becoming maybe too much to put all in one JEP. And I think also the array patterns part of it was just a bit less mature, so they decided to break it out. I don't currently know what the status is on array patterns. All the same, from when that JEP was available or when it was part of it, this is how array patterns would look, which is to say that, we had this array, we could directly reference elements within the array. And again, consistent to what that pattern matching would also do the null checking. So like if there wasn't an element within this array, or if it was null, then it would handle that to where it would just, this instance would fail instead of like throwing some sort of exception, like a null pointer exception, or this check would fail. So that's to say if there was only one element in this array, this check would fail instead of an exception being thrown. Would come back false, that is. This would also even work within multi-dimensional arrays. So yeah, 2-dimensional, 3-dimensional, or whatever dimensional. You could go down that hierarchy and reference directly elements within it and assign it to some sort of value. And then again, it would be null checked and constraint checked. See, sorry, this is wrong. Sorry about that. I need to remove that slide from the kids. Eventually, this will be probably separate from array patterns, or maybe it'll probably be part of that JEP eventually when it's reintroduced. But it's enhanced array patterns. So, like as this currently is, it would be like you would kind of have to have the idea of the size of the array. In particular, if it's like a very large array, this current way of doing array patterns would be kind of very burdensome to get around in, perhaps. But with enhanced array patterns, you could reference direct items within it. So that way, if you wanted to get the last two items of an array, you could just do like get the length of the array and then say, okay, n-1, because, of course, arrays are 0-based, to get the last one, and n-2 to get the second to last one, and then in this case, like add them together. As an easier way, again, of extracting values out of an array, and again, null safety. There's also the don't care patterns. So maybe quickly going back a few here. So like here, really the only item that we care about in all this is the color field in one of these colored point signs. And so we don't really care about like this other one or point even in here. So it can be a bit distracting to look at. So what might be introduced a bit later on is don't care patterns, where we maybe say with like an underscore for other fields within like a class we're checking or a record we're checking, that like an underscore might indicate that we just don't care what value it is in it, or we just might just say only do like a name matching on it to say, okay, I want the field X out of point, just pull that out, and that's what I'm going to work with. I don't really care about anything else. So that can also, again, help make it much more clear. Hey, this is the only element out of this we really care about. We don't care about anything else. So that way you're not getting distracted by the noise of these other elements that you're referencing that just don't really make any meaning for the actual business code in that area. And it could also be pattern matching for each loops. So like here, we already have like an entry and we're going through it, and then we have to like pull out the items from the entry in it. Now we can just, again, a little bit more easily just directly extract the values out of that map entry and then reference them within our for loop. So all that said, you can get access to all these early access builds. Of course, 19 is already available. And then there's also Loom, Panama, and Valhalla. But I would definitely recommend trying to integrate those and check those out. Particularly 19 would be the most relevant, since that's one of the most closest into the future. We also have a great GitHub action for actually being able to easily reference these early access builds. But this could be a really great way just to see, you pull in the 19 build and then to run all your test suites against it or your builds against it to see if any errors crop up. Because we would definitely like to know that if like all of a sudden like, hey, all our tests are passing and now a couple are failing and like there's no obvious like code incompatibility or something like that. That would be good feedback for us to know in case like, hey, some unintended break happened or something else happened. That's how we get feedback, because we're always happy to hear feedback from the Java user base, because that's how we can improve Java. So with that said, thank you. And are there any questions then?
All right, let's see. Do we have any questions in room A? All right, there's a comment. Stole don't care underscore from Golang. That's okay.
That's okay.
Closure stole the async library from Golang.
Yeah. And sorry about that again. Just dealing with this remnants of COVID. One.
All right.
But that actually Stephen does actually bring up a kind of a great point there, and it's something that actually Mark and I were talking about before this presentation, in even a little bit within like the name of what I thought about Amber, which is that Brian calls Java like the last mover advantage, and what often we look at is like, okay, like don't care patterns were successful in Golang, so let's actually then bring them into Java. Because there are times where a language is like, hey, let's try this thing out, and maybe it's successful, or maybe very few users actually use that new feature, and there could be a big cost associated with implementing and then supporting that feature. Because there's also something to keep in mind. It's like, okay, we can add a new feature, don't care patterns or pattern matching, something like that. But then there also comes like a long-term cost with actually supporting that feature of, within the JVM, the security implications and stuff like that. So it's important as new features are added that they are able to support it on our side, and of course that they're able to be successfully used by the user base, the Java developers. So a lot of times we do actually look at what other languages are doing, and if they're successful and it's well liked, we will then bring that in. So some of that is a deliberate goal of just our deliberate decision to actually see what other languages are doing before actually doing them in Java.
It was pretty cool to see these features announced, and now they're part of Java.
Yeah, and really, I'm not totally covering everything. I covered these particular ones because it really kind of gets into some of the pattern matching, the kind of core of Project Amber. But there's other things coming like string templates as well. I think that could make it into Java 19. Again, fingers crossed, don't quote me on it. But that could be very helpful, particularly again when writing things like SQL and stuff like that. And there's a couple other features that are coming up that I forgot to saw about, but haven't had a chance to really research on. So there is a lot of coming for Java into the future as well. All right. Well, thank you very
much. Thank you so much for coming, even though you had COVID. I know it was a little bit of a struggle, but
yeah,
thanks.
Sorry about that.
Appreciate it, and we love Java.
Yeah. All right. Thank you, Mark, and thank you, Philly,
ETF, for inviting me.
All right. Thank you.